What is going on, guys? Welcome to another video in our digital logic series. Now today I'm going to be talking about circuit equivalence. Now what this basically means is I'm getting the same desired output. For instance, if we wanted the value A and B, or A, B not, how could we go about getting this value using the circuits we already know? Alright, so you know what, let's start with something simpler. If we wanted the output of A bar, this is the output we want, okay? How can we go about doing that? We can go about doing that many different ways, but one way we could get this input, as you already know, is we could use a NOT gate, which we have discussed in the very first video. So we have our input here, and we have our inversion bubble, and this would give us an end result of not A right here. So this is what we want. Or we can also go about doing this using an AND gate, and I'm going to show you exactly how to do that. So we could do A as our input, and I want you to pay close attention to this, because if you remember in earlier videos I said that you need to have a minimum of 2 inputs for these AND gates, the AND gates. So this is how we get around that. So if you take a closer look at this, A and itself, A and A, so if A was 0, for instance, let's take A as 0. 0 is going to go through the top wire right here, and 0 is going to go to the bottom wire right here. Now 0 and 0 is going to give us a value of 0. So if A came in here, and for let's do another one. If A was 1, correct? If A was 1, so 1 would be up here and 1 would be down here. 1 and 1 would give us the value of 1, which was the original value of A. So one could say A would give us, oh, you know what? I forgot something here. We need our inversion bubble right here, which would do the same thing, except at the end of this it would invert the value of A. So we would get the value of A bar. Now there's another way we can go about getting the same exact value with our OR gate. So let's see, we have this, and we're going to do the same thing right here, the same logic. We're going to have a minimum of 2 inputs, so that's how we get around that. We're going to have our little inversion bubble right here, A bar. And the reason why this is A bar is because, well, let's take a look at it. Alright, we have a value A. For instance, if A is 0, 0 is going to come in. 0 or 0 is going to give us the value of 0. When we invert that, it's going to give us the value of 1. So 0 was the original value of A. So we could say if A comes in, A is going to be equals to not A at the end of this. Alright, I hope you understood that. I think this is pretty straightforward, and this is one of the ways we establish circuit equivalence. So basically all you need to know is if the output received, oh, I'm sorry, this okay. Now if the output is the same across different circuits, you could say that they are equivalent. Now I hope this video has taught you something. And if it did, and if you like this video, please don't forget to hit that like button down below and comment and subscribe. I'll see you guys in the next video.